Alright guys, welcome to lesson 2, concept B, congruent triangles in the coordinate plane. We're going to step through the example, prove that two triangles are congruent. We're going to go through this just as an explanation along with what is written. So review the proof and select the correct reasons for statement 3 and statement 5. Given triangle ABC, so AB, I went the wrong direction, triangle ABC with vertices at the point A, -2, 2, point B, 3, 3, and C, -1, -3. The line segment AD is a segment bisector of BC. So what that means is AD, this line, segment bisector. That means bi means two, sector, sections. So it cuts BC into two equal sections. So the length from B to D is the same length from D to C. Prove triangle ACD is congruent to triangle ABD. So we are trying to prove that the new triangle ACD, this one, is congruent to the triangle ABD. ABD. So we need to come up with some statements. And I'm going to clear that because it does not come with me when I scroll. Alright. 1. The point A, -2, 2, the point B, 3, 3, and C, -1, -3. That is a given. Statement 2, the distance formula. Statement 3, the line of AB is equal to the square root of 3 minus -2 squared plus the quantity of 3 minus 2 squared, and the distance of segment AC is equal to the square root of -1 minus -2 squared plus the quantity of -3 minus 2 squared. So what is the reasoning here? So A is its substitution property of equality, the symmetric property of equality, or the reflexive property of equality. Well, say that I didn't remember. So what can I do to help myself out? Well, the first thing you can do is click up on a new tab, type in Google, substitution property of equality. The substitution property of equality, one of the 8 properties of equality, states that if x equals y, then x can be substituted in for y in any equation, and y can be substituted for x in any equation. So if you can see, so that is saying, like, if x equals 2, anywhere you would see a x in your equation, you could replace a 2 there. So let's go and look. So we had the distance formula. We had x2, x1, y2, y1. So let's check. Is 3 an x2 value? Yes, right there. -2 is the x1 value. Same thing, y2 was 3 and y1 was +2. So we have the substitution property of equality. Then they did the work, simplifying using the appropriate order of operations. And right here they jumped that the line segment AB is equal to the length line segment of AC. And it's asking symmetric property of equality, transitive property of equality, or reflexive property of equality. So let's use our tools again. Symmetric, I'm going to this one. Should have the 8. Okay, it's a video. I don't want to watch it. I just want some words. So symmetric. Symmetric property of equality. The following property, if A equals B, then B equals A. This is one of the equivalence properties. Okay, let's see if this will give us a list. Okay, so it kind of does. Here's reflexive property and transitive property. So let's read through the other ones. We wanted to see transitive, and here we go. So the transitive property, if A equals B and B equals C, then A equals C. So if A equaled 5 and 5 equaled Y, then we could say A equals Y. There's that link in the middle. So let's look back. AB equals AC. AB equals the square root of 26 and AC equals the square root of 26. So we could also say that the square root of 26 equals AC. So then if we were to use our transitive property, it would flow that AB equals the square root of 26, like they were saying, A equals B, and then A equals B, and then B would equal C. So then square root of 26 equals AC. So then they're saying that A can equal C. So then they're saying that AB equals AC. That's what statement 5 is. So it is our transitive property. Then this is the segment AB is congruent to the segment AC. Definition of congruent segments, because they are the same length. AD is a segment bisector of segment BC. That's a given. So then segment CD is congruent to segment BD. Definition of a segment bisector, that's what we talked about. Okay, reflexive property of congruence. That means the same line is congruent to itself. So AD is congruent to AD. That's the reflexive property. So then we have triangle ACD is congruent to triangle ABD. Side, side, side congruent postulates, because they proved that all 3 sides of both triangles were the exact same. So then we're going to click check answer. It says great job.